There are three types of bonds: ionic, covalent, and metallic. First, let's talk about ionic bonds. Ionic bonds are formed when electrons are transferred from one atom to another. Ionic bonds involve a metal and a nonmetal. An ionic metal with low ionization energy transfers an electron to a nonmetal with high electron affinity. An example would be NaCl. Sodium gives its one valence electron to fill up chlorine's outer electron shell.
Next, we'll talk about covalent bonds. Covalent bonds result from the sharing of electrons between two atoms, specifically between two nonmetals. Covalent bonds are also the strongest type of bond. An example would be NH3. Ammonia is formed when a nitrogen atom and three hydrogen atoms come together. They share electrons with one another in order to fill up their outer electron shell and complete their octet. The last type of chemical bond is metallic bonding. Metallic bonds are formed between two metal ions. The formation happens from an electrostatic force between electrons.
There are also nonpolar and polar covalent bonds. A nonpolar covalent bond is a bond where electrons are shared equally between the two atoms, as in CH4. In a polar covalent bond, one of the atoms has a greater attraction for the bonding electrons than the other. Therefore, that atom will have a larger pull on the electrons. An example is lithium fluoride. As you can see, there is a greater pull towards the fluorine ion.
We can use electronegativity values to determine whether a bond is nonpolar covalent, polar covalent, or ionic. To determine an ion's electronegativity value, subtract the first electronegativity value from the second electronegativity value. If the difference is from 0 to 0.4, then the bond is nonpolar and covalent. If the difference is in between 0.4 and 2, the bond is polar and covalent. And if the difference is greater than 2, the bond is ionic. We will use the electronegativity values from the previous table to determine whether a molecule is ionic, polar covalent, or nonpolar covalent.
First, we will be dealing with a fluorine molecule. So, in order to find the value, we need to subtract F from F. So if we go to the chart, we see that the value for fluoride is 4.0. So we will subtract 4.0 from 4.0 and see that the value is 0. Since the value is 0, it is less than 0.4, therefore it's nonpolar covalent. Notice that it's not it's covalent. It's a covalent bond, and it's a nonmetal with another nonmetal. Next, we will be dealing with a hydrogen fluoride bond. So we will be subtracting the H from the F. So we go back to the chart, see that fluoride is 4.0 and hydrogen is 2.1. We get the value of 1.9. Therefore, it is a polar covalent bond. And finally, we have lithium fluoride. We'll subtract lithium from fluorine, and once again the value is 4.0, and the value for lithium is 1.0, and we get 3.0. So it is an ionic bond. Notice that it is a metal with a nonmetal. Finally, we will be using electron domain geometry to determine whether a molecule is polar or nonpolar.
For our example, we're going to be using phosphorus trifluoride. So to start off the problem, you need to figure out how many valence electrons the molecule has total based on how many valence electrons each ion has on its from its position on the periodic table. So you have one phosphorus ion and 3 fluoride ions, and because of where they are on the periodic table, phosphorus has 5 valence electrons already, and fluoride has 7 each. Totally, the molecule has 26 valence electrons. So when you start the Lewis dot structure, you have phosphorus ions surrounded by 3 fluoride ions. And when you fill it up with electrons, you get 24 valence electrons total, including what you get from the bonds. So you need to add an extra 2 to the phosphorus non-bonding to fill up the full 26. And because it has 4 electron domains, but one is non-bonding, it is trigonal pyramidal in electron domain geometry. and because of this, the 3 fluoride ions pull the phosphorus ion a little more than the non-bonding, so it's not symmetrical, and therefore it is a polar molecule since the electrons are not shared evenly.